Hey guys, you've been learning about different types of solutions, so we're just going to do a refresher and make sure that you understand the difference. So diffusion is solutes moving from a high concentration to a low concentration. Think of it kind of like a waterfall. It moves up to down. Whereas osmosis is the same thing, but it's only water that's moving. So we're going to talk about three different solution types, and then I'm going to help you guys get ready for the worksheet that I have for you. So let's start with hypotonic. I kind of remember hypo and that it's kind of like a hippo. And an easy way to remember that is that let's say we've got a beaker right here. And let's say that I put a fish in there. I'm going to put a saltwater fish in there. So I'm going to draw a bunch of salt so you can see that there's a ton of salt in this saltwater fish. But I didn't know a lot about saltwater fish, so I put it in a freshwater tank. Now what's going to happen here is that there's a higher concentration of fresh water out here than there is inside of the fish. So water is going to move into the fish's body. That's not going to turn out super well for the fish. In fact, the fish is going to start to swell up so large that it might in fact do something called lyse, and that's when it kind of explodes on a cellular level. Not such a good thing. Okay, next we're going to talk about hypertonic. And that would be a situation where, let's say I've got a freshwater fish and I put it in a tank of salt water. I'm not a very good caretaker for my fish, or am I? So if I put this freshwater fish in a saltwater tank, because there's more water molecules inside of the fish's body than in the tank itself, water is going to actually leave the fish's body and it's going to shrivel. It's going to shrivel up, look kind of gross. Both of these don't turn out so well for the fish, right? So ideally, the type of solution that you want to put your fish in would be an isotonic solution. Iso means equal. So we want it in an isotonic solution. So let's say that I have my little tank here and it's fresh water, and fresh water is still going to have a couple little molecules of something, and I'm going to put it in with a freshwater fish. Because the molecules are equal, they're going to move, the water is going to move in and out of the fish at an equal rate. And because of that, the size of the fish will not change and the fish is going to maintain its healthy kind of life. So this is what we want. Now you should have this worksheet now. Sorry. And you're going to be working on this. Now what I want you to look at, let's start with this one right here, is that we've got 90% water inside of this cell, and it's in a beaker that has 85% water. Now remember that it's moving from a high concentration to a low concentration, so we're going to look at the water here. There's 90% water, 85. This is obviously a higher concentration, so water is going to move out of the cell. The cell is going to shrink a little bit. So what type of solution does that mean that it's in? If it's shrinking, that means that it's in a hypertonic solution. So what you can do, you can either look at the water or you can look at the solutes. For water, just know it's moving from a high concentration to a low, but depending on how many solutes are on the outside of that cell, it's going to depend on whether or not that water moves towards that direction. Let's take a look at the back side here. One of the things that you've got to know is that on the inside of the cell and the outside of the cell, it should be 100%. Whatever the water is, the solute makes up the rest. So if I've got 10% solute here, then this totally needs to add up to 100. So that must mean that I have 90% water. And if I've got 20% solute on the outside of the cell, again, it needs to add up to 100. So that must mean that I have 80% water outside of here. Now we're looking for the high concentration to a low concentration. Inside the cell is 90%, outside of the cell is 80, so water is still going to move out. That means the cell's going to shrink a little, and this one again is hypertonic. Let's look at this one right here. The solutes are the same. That means that the water is going to be the same, and they add up to 100, so that means they're both going to be 90. If they're both equal, that should remind you of the solution type that means equal, and that's isotonic. That means that water is going to move in and out at an equal rate. That's what we want. That's a good thing. In fact, if you've ever been to the doctor and had to get an IV, you might even notice that on the bag itself, the IV bag, it says isotonic solution, and that's what you want. If you were to be given a hypertonic solution or a hypotonic solution, you might have the same fate of those fish. Not such a good thing.